Next up in our concepts in review, we are going to talk about projectile motion. And more broadly, these rules kind of apply to motion in two dimensions, 2D motion. So we'll have stuff going on in the x and the y direction. Now, the first thing that I need to mention on this as to equations are the kinematic equations. Those ones that I mentioned in the last section, in particular the handful that I really emphasized, but the kinematic equations are how you want to go about this. There exist equations out there for projectile motion. In other words, the range equation. I'm not even going to write it down here because I think it's kind of not a good thing to invest time in. You're welcome to disagree with me, and you're welcome to look up the range equation and remember it if you'd like. If you do, you must remember that the range equation only works if you have projectile motion where you're on flat ground, where you come back to the same height. Most of the ones that we look at involve a cliff of some kind, at which point your range equation will not work. That's one of the reasons why I don't think it's really worth the time of memorizing it. All right, so kinematic equations are the key. A couple of things that I want to mention. If you watch the videos that I have related to them, I will remind you that kinematic equations with projectile motion is one of the first places where we start dealing with 10 or sometimes even more variables. And so it becomes very difficult to keep track of all of our information. It's the first time that we used a table or a chart. I even had you guys using the chart effectively in one-dimensional kinematics, but we just had x. I will remind you what the chart looks like. We had delta x, we had v initial in the x direction, v final in the x direction, we would have time, and we would have acceleration in the x direction. Over here, for the y, we would have all the same things except for the y direction. And notice that I don't put subscripts on t, on the time, because these are our bridge between the two. The time it takes for a projectile to travel however far it goes in the y direction, so up and down when it hits the ground, versus the amount of time it's traveling in the x direction until it hits the ground. Well, it gets launched at the same time in both cases, and it hits the ground at the same time in both cases. Time is our bridge between these two dimensions. Everything else can be completely independent, but the time that it's in the air is the same for both. Big things to remember on this. Acceleration, under most circumstances for projectile motion in the x direction, is 0 meters per second squared. Acceleration in the y, negative 9.8 or 9.81, or sometimes just 10, depending on what you need for whatever exam you're dealing with. But it's the acceleration due to gravity with a negative, because we normally set this up where positive x is to the right and positive y is up. Now when you're dealing with a cliff like this, keep in mind that your delta y is also often negative. It's a negative number. Keep track of direction. Remember, delta is not just change. Be careful with that memory. Most people will respond whenever I ask, what's delta mean? It means change. That's limited. That won't get you whether or not it's a positive or negative. Delta is always final minus initial. In this case, we start off maybe here at 40 meters, and we end at 0. So that's 0 minus 40, giving me negative 40 meters for my delta y. Always remember that. Now, you can solve these more directly, and oftentimes you'll find that you'll be given an initial velocity. This is where our vectors come in. We're given an initial velocity at some angle theta v naught. You'll need to find your x component, where you will often find that it is v naught cosine theta, it being the adjacent side, and your initial y velocity is v naught sine theta, because it's the opposite side, and here's your hypotenuse. So that's how you get your initial velocities. You put them up in here. That fills in your information. Oftentimes what you're looking for, because it's your bridge between these two, is your time. So you will have your acceleration in the y, you'll have how far you go, and you'll have your initial velocity. You'll use that first equation, that one that I said was very, very useful in kinematics, and you can solve for it, but you'll find that you'll have to deal with a messy quadratic. Now, you can deal with the quadratic. It's whatever you're comfortable with. It would save you a little bit of time. I always have trouble figuring out which between the two answers is the one I'm looking for, because not always will you end up with one of them being negative. So the thing that I recommended to bypass this is fill in another part of the chart. Find your final velocity in the y direction. And then you can use a non-quadratic equation to find your time. Make certain that you're comfortable with that, or if you prefer, go with the quadratic approach. In either case, that's a way of going around it. The one thing that I will remind you of is when you're dealing with your final velocity in the y, ask yourself, is it going up or is it going down? Because most of the time, it's going down. You need to remember that negative, or else it's going to throw everything off. Okay? So remember those. You find your time. That lets you bridge over to the x direction and fill in whatever you want, much like any of the other tables or charts that we have used before, where you've got a whole lot of variables. If you get stuck and you don't know what to do next, do what you can to start filling in these numbers. As long as you can fill in some of the numbers, you're making some progress, because you may not be able to see exactly how you're going to get what you're looking for, but if you start filling things in, you've got more information and it becomes even easier. But the absolute fundamental key to these projectile motion problems is the time. The time is your only bridge between these two dimensions. So I think that covers all of that. Can't remember if there was anything else. We talked about keeping an eye on the negatives in particular, and we're going to talk about this again. The acceleration in the y direction, I always used a sub y when we did this because we used negative 9.8. Later, when we start using the acceleration due to gravity in our force equations, we're always going to use the positive. We're going to keep track of the negative when we start dealing with directions in our free body diagrams. But this is projectile motion in review.